second link for slides that we're going to go through today is sort of working with shell profiles and academic compute clusters and some UNIX extras. So we'll see how far we get into this in the 25 minutes that we have. Whatever's left over, we can pick up on Thursday. First thing I want to talk about is this sort of confusing and somewhat magical file called your bash profile. And I think we've talked about this in the past. I showed you how to make an alias. Let me just set this up a little bit with an example. So let's say that I find myself constantly needing to sort bed files by chromosome and then by start coordinate numerically. But for the life of me, I just can't remember the syntax of sort. So I know it off the top of my head because I've typed it roughly 1 trillion times. And so I can just find the bed file here. I'm sick of forgetting or getting this wrong. So I can just make an alias, which is, I'll just call it bed sort. That's wrong. So let's try that, bed sort. Yeah, okay, that worked. Let me just make sure. Okay, so the whole point is this bed sort. If I remember, like, it's easier for me to remember, oh, I want to sort a bed file. So I made this little, fancy command called bed sort, which is just a shortcut, right? The problem is, as soon as I log off of Malibu, that thing's gone. That alias only lives for my session, the time that I'm logged in. So this is the whole motivation behind, this problem is the motivation behind your bash profile. Bash profile is a little file, text file, that contains a set of commands that are run every time you log in to a particular machine. So what happens behind the scenes is when you SSH your unit at malibu.chpc.utah.edu, you don't see it, but what's happening immediately is it recognizes your user by your unit. It goes to /home/your unit and looks in your home directory for a file called bash_profile. If it finds one, before it gives you your prompt, it runs all the commands in that bash profile. So for me, for instance, my bash profile on Kings Peak is really long and it has a bunch of commands that take a little bit of time. So I log into Kings Peak and it sits there and I don't get my prompt for almost a full minute because it's running all these commands that are essentially the setup or the boot sequence for logging into Kings Peak. So it's kind of the same thing when you reboot your laptop. There's a series of things happening. Your computer is trying to like bootstrap itself. It's loading up the operating system, but actually it's doing the same thing for you. It's running your default settings. Like if you had default font settings and like colors and screen size, that's the equivalent of what's happening in bash profile. It's like your setup script. Okay. So the trick is this file, it starts with a dot, and so by default it's hidden. So if I go to my home directory, cd tilde, and I do ls, there's a bunch of junk in there, but there's no dot dash profile. But if I do dash ls dash al, let's just do ls dash a, that means all files, hidden or non-hidden. And when I do that, I see this bash profile file. Okay, it is nothing more than a text file, and it the first line is just a header line to say this is the name of the file. It's called dash profile, and most operating systems include automatically in your bash profile this little script which basically says run this up in addition to running what's in this bash profile file, also execute this other file called bashrc, which I'll come to in a minute. So This bash profile that I have for my home directory on Malibu does nothing. It's not very useful. It's basically just the template. There's no customization that I've made. But now I'm going to show you how to customize. So let's take that alias that I created, and we're going to add it to our bash profile. But to do that, we need to learn something new that you haven't learned before, which is how to edit a file in Unix. There's a couple of ways to do this. There's a command called nano, which is like a little basic text editor. But the one I want to show you is vim or vi. There's two versions. There's vi, or there's, if I type vi and enter, it'll actually run vim by default, which is vi improved. Okay, so when you type vi and hit enter, it launches this text editor. The first thing I want you to see is this shortcut. One of the jokes about VI is that people just get trapped in here forever because they don't know how to exit. VI is a kind of a strange program. You can switch between two modes. One is called command mode, and the other mode is editing mode. So just a quick aside, when Apple came out with its little touch bar thing on the MacBooks, they got rid of initially a formal escape key, and the escape key was buried on the little touch bar. And that angered Vim users tremendously because what you spend most of your time doing in Vim is hitting the escape key to switch between command mode and editing mode. So to edit or to do anything, let's actually just work on to get out of Vim and get back to the command prompt. The way you do that is you hit escape, and then you hit colon, and you notice down here at the bottom, as soon as I hit colon, it puts me in command mode. Okay, and I can hit, then type Q for quit. And if you notice, that's exactly what it's shown here. To exit, you type colon Q enter. But what's not really said there is if you're in editing mode, you can't just type colon Q then enter to exit. You have to get into command mode. So you first have to type escape. So in a nutshell, to exit Vim, hit escape, colon Q enter. Okay, so let's do it again. Go back in and hit escape, colon Q enter. Okay. All right, so when I was running VI or Vim there, I was just not telling it what file name I wanted to edit. So I can do VI bash profile now, because what I want to do is edit my bash profile. Let me put this little script in chat for you if you want to add it to your bash profile. So you can play along at home. So I'm going to now edit bash profile, and aha, now we see the contents of what was in that file, bash profile, that I catted to the screen. What I want to do now is I'm going to use my arrow keys to move to the, I'm hitting the arrow key to go down to this line between FI and this line. And if I hit escape and then I, what you see is now the mode of Vim has changed to insert, and that means your typing mode. So what you can do now is take that command that I pasted into chat, and you can paste it here. Right? Now, so what we need to be able to do is save this. So just save. Again, you're going to hit escape. You're going to hit colon. And now instead of Q, what you're going to do is say W for write the changes, or save. This is the equivalent of save, and hit enter. Okay. And now what it says is that 8 lines, 174 characters are written. So it's updated the contents of this bash profile file. Let me do that all over again. I know I went kind of fast. I've scrolled down to this line. I've hit escape, and then the I key for insert. You take, and at this point I can type whatever, chmod, whatever. But I can also just go to my chat and copy and paste right in there. And to save this, we do escape again. Again, everything goes through escape and colon W, and we saved it. Now, if we want to get back to the prompt, we do escape colon Q to quit. So now if I cat dash profile again, I can see that the contents of this bash profile have changed. Okay. So let me just show you. If I hadn't done this and I log out and log back in, if I type bed sort and I hadn't updated bash profile, it would say I have no command not found. What's bed sort? But now that this alias is in my bash profile, actually, and let me just do one more trick so we can see that it's running my bash profile. Let's say echo and VI is really. Okay. I'm going to do escape colon W to save that, escape colon Q to exit. Let's see. Okay. So if I exit Malibu, now I'm on my computer, my laptop, and I want to SSH again. Remember that what's going to happen is when I log in, it's going to validate my password. As soon as it validates the password, it's going to look for a bash profile script in my home directory and run it. All right, so I have to just pick out one. Okay, see, it printed out that echo VI is really confusing. So if you want to put in a little message to yourself every time you log in, a little encouragement, you can do that. You can have it download the file every time. You can put whatever you want in there. But now here's the trick: bed sort will work. Okay, that alias now is provided to me every time I log in. Another thing you can do is you could alias grep for grep -- color, so that you always get your matches highlighted, that type of thing. You can do whatever you want. So if you found some tips along the way, or found another one that is kind of obvious is that sed command that we always do. This could be used to just make this an alias, which is remove Chrome, whatever you want to call it. You could put that in your bash profile. Okay. All right. That's bash profile. Any questions about that? Okay. It's basically your boot up script. There's also this bashrc command. So this is totally baffling to me. I don't really understand the history behind this, but bash profile is executed each time you log into a machine with a username and password. Bashrc is its friend, and it's executed each time you open a new window once you're already logged in. Now, this is something that you typically wouldn't be doing on Malibu, where you basically log in and you have one session, and you're usually not launching new terminal windows from that. You basically have to be on that physical Malibu machine. But it's similar on OS X. Like I've got terminal open right here. If I do Command T, I think, yeah, it'll open a new tab for me, new terminal window. And in that case, it would be running bashrc. I'm already logged into this machine. Except That's the way it normally works on any typical Unix machine, except on OS X, it always just uses bash profile. It doesn't actually run the bashrc command. So that's why this bashrc, because it's run every time you open a new window, that's why this bash profile also calls bashrc, so that when you open your first window, when you log in, it's uniform with what it would be if you open a new window once you've logged in. I know that's a little bit confusing, but for the most part, I would say do all of your customizations in your bash profile, because that's the file that is going to be typically executed in the way that we normally use the academic compute environment, which is you log in with SSH and you're continuing to work just in that one window the whole time. Okay, a couple of other commands I want to show you. This PS command gives you a report on a process status. It'll tell you like basically just what's going on, if it's running, if it's killed, if it's running in the background. So let me show you how that works. We did that for loop. Here's a for loop that I ran in the background. Oops, I gotta go into the right directory. Demo. So check out this number. That's a process ID. That is running. So I can say PS, and if I give it that process ID, the status will be that it's, I actually don't know what status SS is, but the command is running, it's basically saying it's running bash, because this is a bash loop. Okay. And then, so if we wanted to figure out why do we want to figure out the process ID? Well, one thing that you could do is, let's say I said I want to run this 1,000,000 times. That process 1135904 is going to be running for a long time. But I go get a cup of coffee and I come back to my desk and I looked at this command again and I say, oh, I made a mistake. That command's wrong. It's not doing what I want. What you may want to do is just kill that command. See, I can just say kill and then the process ID to end it. Okay, and immediately that process becomes terminated. Right? That's a common. I mean, you know, we make mistakes, and if it's going to be a long-running mistake, it's often worth just killing the command to get a sense. But what if you didn't note the process ID when you first launched the command? Well, there's another thing that you can do. So I've gone through process and kill. Kill is just to terminate. The other thing that's really useful is the so-called top command. I actually don't really know why it's called top. I guess maybe like the top most intensive processes on a computer. That's all I can think of. I'm totally guessing. But let's run this command again. It's going to run forever because we're doing this Monte Carlo simulation like 1,000,000 times now. I cleared my screen. I lost track of that ID, that process ID. I went and got coffee again and realized I messed it up again. So if I type top, what you get is this interactive, constantly updated, like every 2 seconds or every second. It gives you a list of the top running commands. So you can see that bed tools is up here, bash. Looks like user 1209808 is running this command again. Good for you. And I can see the process ID. So there's my process ID. Now I can select that process ID. I'll take this one. Oops. And okay, so to get out of top, it's just like less. You have to hit Q to get back to your command line. Now I can just say kill and the process ID, and there it is. It's terminated. So don't despair if you didn't track the process ID and you realized you made a catastrophic mistake. You can just use top to figure out what the process ID is. The other thing that's nice with top is you can just use it to track what's going on your computer. This is kind of like on Windows or Mac. It's called like Activity Monitor. That's basically just a fancy version of top. It's just showing you what processes are running, how much CPU they're using, how much memory, stuff like that. Okay. And so, yeah, so top is just a status monitor, really. All right. In the last 5 minutes, what I wanted to show you is this chmod command, which I've talked about a little. I think I did it in real time in one of the classes. This is to change the mode or the permissions of a given file. So one of the things that we often have to do is make something executable. And you've probably seen me do chmod plus to add, and then X for executability. So we have to do that to bash scripts and stuff like that to make them executable. That's basically how UNIX recognizes that that program can be executed. It has to have the mode. You have to change the mode to be executable. Okay, so the chmod command, let's just I'm gonna make a little file, and you're gonna learn a new command here called touch, which is to create just an empty file. We're gonna create an empty file called test file with the touch command. If we do ls, you can see that there is a test file here. You can see that 0 bytes, there's nothing in it. And then there's this kind of weird thing over on the left, which is, you know, R's and W's and sometimes X's and sometimes dashes. This is a printout of the permissions for that file, and it's broken up into 3 groups. There's always a first bit at the beginning that is a dash, and that has to do with the operating system permissions. But then after that, there's 3 groups of 3 characters. This group, that group, and then this group. The first 3 characters represent the user's permissions. So the person that is logged in, what is that person's permissions when they're looking at this file? The second group is the permissions for the group. So there's this notion of UNIX groups. So all the people in my lab, for instance, belong to a particular group. So you can define permissions. You can say, all right, I'm going to let everyone in this group be able to read the file, but no one in this group, that type of thing. And then the last is A for anyone. What are the rights for any old person logged into this machine? Okay. So the first byte in each of these groups of 3 represents whether or not it's readable. So if it's an R, it's readable. If it's a dash, it ain't readable. So in this case, and then the second one is writable. If it's a W, that means the user in this case can write to this file. But the group cannot, nor can anyone. And then the last byte is executable. So this file, test file, is not executable by me, by the group, or by anyone. Okay. So the way that, so if you think about this, if you break it down, you've got these 3 triplets of read, write, executable, group, read, write, executable, and so on. So behind the scenes, each of these yes or no, is it readable? Yes or no, is it writable? Yes or no, is it executable? Are just bits, true or false, 0 or 1. If all 3 bits are set, that's 2 to the 0th power plus 2 to the 1st power plus 2 to the 2nd power. So 1 plus 2 plus 4 equals 7. In this case, just the first bit, or 2 to the 0, which is 1, is set. And the third bit, which is 2 to the 2nd, which is 4. So 4 plus 1 equals 5. And in this third example, for everybody, nothing is set, so the value is 0. All right. If you did chmod 777 to a particular file, let me just do that. That sets every bit for user, oops, you can't see what I'm pointing at, for user, group, and all to be true. So it'd essentially be this if I did 777. And let's take a look to confirm that. Yeah, every bit is lit up. So anybody can do anything to this file. Not good practice, probably, not the most secure setup. So let me just return this back. Right. I don't like to think about the bits that need to be set. I like to think about the operations. So in this case, let me just remove this file and do it again. Touch it. Now we've got this same file again. Now let's say I want to make it so that anyone can write to this file. Okay, so I'm going to do chmod A for anyone, and I'm going to add writability. Now we're going to look at it and look. The only thing that changed is this bit for writability for anyone got set to true. So now anyone, I mean, this is kind of stupid of me, any one of you can, well, if you could get into my home directory, you'd be able to delete that file or modify it or whatever. Probably don't want to do that. So I'm going to stop there. Chmod is how it's a lot of what we end up dealing with when working with data files or new data files within a lab or as a collaboration is messing with permissions so that the right people can do the right things to the files. So it's useful to know this chmod command. Also, sometimes when you download software from the web, like if it's a Python or a Perl script, you're basically just downloading a text file and you'll go to try and run it, but it doesn't do anything. That's typically because you just downloaded a text file from the internet and you need to tell UNIX that it's executable. So you need to do something like this, chmod A plus X for executability to that test file. And now what you've got is it turns it green and it added that X bit. So now if there is actually code in here, let's just make some code quickly. It's not funny if I don't spell it right. All right, we'll get out of there. And now that it's executable, I can do /test file and it'll actually run something. If I got rid of that executability, chmod A minus X, oops, no longer can I run it, permission denied. Now if I add it back, yeah. Okay, so we're going to stop there because I'm past time with chmod. Next time we're going to pick up with some additional UNIX tricks that I want you to learn and hopefully start diving into the normal distribution and its useful properties for science. Any questions? Sorry.
I was wondering, how do you know, or how can you check what group you're part of?
Great question. Thank you, Michelle. I think you say groups. I haven't done this in a while. Yeah, groups. It's a hideous mess here, but this is a list of all the different groups that I'm a part of. The other thing that, just quick, any other questions related to that? There was another person who was running a command earlier. I was hoping to find their unit, but you can also do things like, if you see a unit ID, you can say who is, and I'll just say U1007787, which is me. No, never mind. Who is isn't installed on Malibu, but it is on our academic compute cluster. The reason this is useful sometimes is if someone has submitted like 9 billion jobs to the compute cluster, which we'll talk about next time, you can, or if they're doing things badly on the head node, which we'll talk about next time, you can figure out who that person is and email them or report them if they're not being a good citizen on the compute cluster. Yeah, so to Michelle's point, often you need to know what groups you're part of because you might know that a file has permissions within a certain group, but so you want to know, am I part of that group or not, if the permissions aren't playing right or aren't behaving the way you expect. Any other questions?
I have one comment just for the homework.
Yep.
For question, I guess maybe all of them, but just pay attention to the order of the samples. It looks like the child is 4805, and that's the third of the three, and not the first, which I think I implied yesterday.
Cool. All right, any other questions? Okay, well, I'll see you all on Thursday. Take care.